Hi, you guys. I wanted to quickly go over each of the problems that were on your test so that you can do your test corrections. Make sure that you're following along, figuring out what you did wrong, and then once you're done with your test corrections, there is an ALEKS assignment that's called Variable on Both Sides Retake Extra Practice. And then once you've done that, you can retake your test. You will have to retake your test in my class. Because there is a password on it. Okay, so here we go. Whenever you're solving an equation, remember the very first thing you want to do is you want to look at the left side and you want to see if anything can simplify. So when I look at this left side, I have two like terms here, 3/8 times x and 5/8 times x. So when I add those, it's 8/8 x, which is the same as 1x. So on my left side, I'm left with x and a -6 equal to a -14. And then remember, whenever you're solving an equation, you're trying to isolate your variable. So the only thing we need to do to get that variable by itself is to add 6 to both sides. Now, one of the things you have to be super, super careful with when you're solving equations is you have to make sure you do your integer operations correctly. So if you're still having a hard time with that, make sure that you think about it in your mind as far as like what you think it should be, but then you need to check it with the calculator, okay? So this is -14, a +6, which would be a -8. Okay, now on the next one, we're going to do the exact same thing we just did. We're going to first check the left side of our equation. Now on the left side this time, we have a 0.4 that's right next to our parentheses, and that's got to distribute to both of these. So that ends up being a 2x minus 4.8, and then we have a positive 0.5x. Now, after we distribute, we have to combine like terms, and so we're going to combine this 2x, this positive 0.5x, that gives us 2.5 times by x minus 4.8 on the left side. Okay, now we look at the right side. There's nothing to simplify here, and so now we continue with getting our numbers to the right side so that in the end we have variable terms on one side, numbers on the other. Here's my variable term, 2.5 times x. So I want to isolate that by adding 4.8. I want that 4.8 to not be on the left side. I want it to be on the right side. So now I have 2.5 times by x equals 20. And then we divide by 2.5. And that gives us an 8. Now remember that when you're putting this in the calculator, it's the 20 that's being divided by the 2.5, and it does matter that you put the 20 in first. Okay, next one is an equation with the variable on both sides. So first thing we want to do is look at the left side, see if there's anything to distribute, any like terms to combine, which there's not. So then we're going to look at the right side. We're going to do the same thing. We're going to see if there's any distributing to do or any like terms to combine, which there's not. And so then we want to bring our variables to the left side and our constants to the right side. So I do not want this variable term, this 4x, on the right side. So I'm going to subtract 4x. Now when I do a 4x and a -4x, that totally cancels each other out. There is nothing left. There's not an x left. There's nothing left. The only thing that's left on this side is a 1. Okay, now if I subtract 4x from the right side, I've got to do the same thing on the left side, because whenever you're solving an equation, whatever you do on one side, you've got to do the same on the other to keep it balanced. So 8x and a -4x makes 4x. And then the next thing I'm going to do is I am trying to isolate the variable, right? I want this variable to be by itself. So we're going to have to get rid of that multiplication of 4. And we do not want the 9 on the left side. So I'm going to subtract 9, so that I end up with my variable term on one side and my constants on the other side. And then last step is to divide by 4, so x equals -2. Okay, next one. You can see that these are getting progressively harder, right? We started with 2 steps. Now we're moving to, and then we move to a variable on both sides, an easy one. Now we're moving to a variable on both sides where we need to do a little bit more work. Okay, so first thing we do is we check the left side. We can see that on our left side, there's nothing to distribute, but we do have some like terms to combine. I can combine that 1x and the 3x, and that's going to make a 4x minus 21 equal to, and then on the right side, I'm going to combine the negative 7 and the negative 14, which is negative 21. My next step is I want to bring all my variables to this side, all my constants to this side, right? I want one side that has my variable terms, the other that has my numbers. So I want to get rid of this 3x that's on the number side. I want it to be on the variable side. So I'm going to subtract 3x from both sides. I'm going to bring that over here, which leaves me with x minus 21 equals a negative 21. And then remember, this was my variable side, this is my number side. So this negative 21 needs to be on the other side. And when I do that, I get a negative 21 and a positive 21, which is a 0. That is my solution, okay? And back up here, when you were at this step, I want you to recognize that on both sides, we have a constant of a negative 21. And so the only way that we can make this equation equal is if we plug 0 in for the x. Then we would have a negative 21 equals negative 21. Okay, next. Okay, number 5. Okay, so on this one, we want to distribute on the left the negative sign. Okay, this negative sign right here, that is what is next to the parenthesis. So we distribute that as a negative 1. So that's going to be a negative 2x, a positive 3, and I still have that 5. So now when I combine like terms, on the left side, I'm left with negative 2x plus 8. On my right side, when I combine like terms, I'm left with negative 2x plus 8. Now, when we look at where we're at right now with our equation, the coefficient of this variable term is negative 2. The coefficient of this variable term is negative 2. Our constants are 8 on both sides. So both expressions on the left and the right are exactly equal. Whenever this happens, the solution to this equation is all real numbers. You can plug anything in for the x and it will make that equation true. Now, if you continue to solve by collecting variable terms on the left side, the negative 2x and the positive 2x totally cancels out. There's nothing left there except for an 8 on the left. There's nothing left here except for an 8 on the right. So when that happens, if your variable term drops out, you're left with a statement that's true. That's another way you know your solution is all real numbers. Okay, let's keep going. Okay, number 6. First step, distribute, and then combine like terms. So on the left, negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. I still have a positive 4x on that left side, right? This is my left side. So now I'm going to combine like terms. So on my left, I end up with 2x plus 2. And then on my right side, right here, I'm going to distribute that 3, which gives me 6x minus 6. Now, from there, I want to collect my variable terms on the left, my constants on the right. So I'm going to minus 6x minus 6x, which gives me negative 4x plus 2 equal to a negative 6. Then I'm going to subtract 2 from both sides. So negative 4 times x equals a negative 8. And then to get rid of that multiplication of negative 4, I divide negative 8 divided by negative 4 is positive 2. Okay, next one. Now on the next one, we have a fraction next to our parenthesis, but it doesn't matter. Fractions, decimals, integers, we can work with all of those different forms of numbers. So first step, distribute. 1/10 times x is 1/10 x. 1/10 times 50, multiplying by 1/10 is the same as dividing by 10, so that's going to be a 5. And then on my right side, I am going to combine the negative 3x with the positive 4x, which is a 1x minus 13. Okay, now at this step, you need to recognize that the coefficient of this term is a 1. So when I collect my variable terms on the left side, I'm left with negative 9/10 x plus 5 equal to negative 13. And then I'm going to subtract 5 from both sides. So negative 9/10 times by x equals negative 18. Okay, now from there, this negative 9/10 is being multiplied by x. So the way that I cancel out a multiplication is I use division. So the negative 18 has to go in the calculator first, divided by negative 9/10. And it's super important you put the 18 in the calculator first, because when you divide fractions, you really multiply by the reciprocal of the second fraction. So if you don't put that in correctly, you're going to come up with the wrong answer. The answer for that one should have been 20. Okay, next one, number 8. We're going to distribute the 5, which is 20x minus 20. On the right, we're going to distribute the 10, which is 20x plus 40. Now, at this point right here, you should recognize that the variable terms on both sides is the same. The number of x's is the same on both sides. Sorry, I did this one wrong. 5 times negative 80 is negative 40. Okay, now my constants are different though, right? And so when I subtract 20x from both sides, there is no x left. The only thing I have left is negative 40 equal to positive 40, which is not a true statement. And back in the beginning, if your constants are this, your variable term is the same, but your constants are different, there is no solution to this. There's nothing you can plug in for x and multiply it by the same thing, but then add 40 on one side and subtract 40 on the other and have that be equal. So on this one, you should have said there is no solution. Okay, so this one, if your variable drops out, you're left with a statement that is true. You would say there are infinite solutions. Number 11, when you simplify the left side, you still get 3x minus 7. There's nothing to simplify. When you simplify this right side, you get 3x plus 7. Okay, so now when you go to solve this, you're going to get negative 7 equals positive 7. Anne says that the equation has no solution, and you would say yes. She is correct because the number of x's are the same, but the constants are different. Okay, last question. A mountain gorilla weighs 135 pounds and is gaining 1/2 pound per week. An eastern gorilla weighs 143 pounds and is losing 1/4 pound per week. We want to know when these two gorillas weigh the same. Okay, so this is the equation that you should have set up. And then from there, you're going to add 1/4 x to both sides, which gives us, sorry, I'm out of space. I'm going to have to bring it up here. 3/4 x. Okay, then we're going to minus 135 from both sides, which gives us an 8. Now, on this last step, we're going to divide by 3/4, divide by 3/4, and when I take 8 and I divide by 3/4, I'm really going to multiply by 4/3, so my answer is 32/3. Some of you put 10.6 repeating because that's what it ends up being as a fraction, but there you go. There's your test corrections. So next thing I need you to do is do the variable on both sides, retake extra practice, and then you'll need to come in before school, after school, or during den time to retake your test.